Hey everyone, in this short video, we'll discuss the extreme values theorem. So the theorem says, if a function f of x is continuous on a closed interval from a to b, then both absolute minimum and minimum exist on that interval. So that means if you given a continuous functions on a closed interval, then you guarantee to have both absolute extrema, minimum and maximum. The question is, how could we find those values, right? And here are some steps on helping you to locate absolute extrema. The first step is you want to locate all the critical values by first finding the derivative of the function, and you look at the domain of the derivative to find if there's any point such that the derivative of that point is not defined, right? Any point of the derivative functions that would make the functions undefined, you find all of those points. And then you solve for f prime of 0 equal to 0 to find all the points such that the derivative at those points equals to 0. So you set f prime of x equal to 0 and you solve for x, and those points are going to be some of the critical values. So again, critical values are the values such that the derivative equal to 0 or the derivative doesn't exist. All right, the next step is you make a table, including x value and f of x. What will you have for x values? You have critical values. If you found two critical values, he wants you to list it there. And endpoints. So we have the endpoints is a and b, right? Because this function is closed, continuous on a closed interval from a to b. So you include critical values and endpoints on the x column. And the f of x is just finding the function value at those points. And the last step is making a decision, right? By looking at the set of f of c1, f of c2, f of a, and f of b, the set on the right column, the function values at critical values and endpoints. And then you find the maximum value, like the highest value among these values, to be the absolute maximum. And you find the minimum, the lowest value, to be the absolute minimum. All right. So look at it. So you want to look at, find all the critical values, make a table including critical values and endpoints, finding all the function values at those points, and picking the maximum value to be the absolute maximum and the lowest value to be the absolute minimum. Now let's look at an example. If you want to find the absolute extrema of the function f of x, ex over 1 plus x squared on the interval from 0 to 3, then you list all the steps, right? Locate critical values, make a table, make decisions. Well, in order to locate all the critical values, you have to find the derivative functions. I use the quotient rules to find the derivative of this function. And since you look at the numerator, you have each of the x as a common term, I factor each of the x out. Okay, and I look at the domain of these functions because the denominator is a perfect square term, so there will be no points in which the function is undefined. So that means the domain of this function is from negative infinity to positive infinity. Then I solve for f prime equal to 0, right? Because the denominator is always positive, then I just need to take the numerator, set it equal to 0. And because each of the x is always above 0, so the only equation that comes up is x squared minus 2x plus 1 equal to 0. And this is a perfect square, x minus 1 squared equal to 0. So I have x equals to 1 is the only critical value that I found so far. And that's the only critical value of this function. So now when I make a table, I include the critical value, which is 1 that I just found, and the two endpoints, 0 and 3. And I go in and find f of 1, f of 0, and f of 3. And I compare these three values, e to the 2, 1, e cubed divided by 10,
And it turns out that e cubed over 10 is the absolute maximum, and 1 is the absolute minimum. So I found the two absolute extrema, one maximum and one minimum. Now it's your turn to try. Find the absolute extrema of these functions on the interval from 0 to 3.